You are listening to The Vocal Technologist. Spoken Tech for your ears.
What if you could clock off work, hand your laptop over to an invisible intern, and just wake up to find your entire project finished, tested, and, ready to ship?
I mean, it sounds like a highly specific corporate fever dream, to be honest, or just pure science fiction.
Right. It sounds completely absurd, but that is exactly what is happening across the technology sector currently. We are moving away from treating artificial intelligence like a chat box you just politely type questions into. Instead, we are literally handing over the mouse and keyboard to autonomous agents that actually do the work for you.
Yeah, it is a massive pivot. And we need to look under the hood of this transition, because if the machines are moving from taking our questions to taking our actions, we have to figure out what the human role actually becomes when all that heavy lifting is automated.
Spot on. So we are going to unpack the massive hardware upgrades required to run this new digital workforce. And we will pull apart some incredibly wild physical tech that is bridging the gap between software and reality. And we're going to do all of that without making you sit through a computer science degree.
Which is always a bonus.
Exactly. Look, if you are listening to this, you already know the basics.
Yeah.
You know what a processor is, you know what code does. But before we can understand the physical robots being built for the real world, we have to explore the invisible robots taking over our desktop software. Look at OpenAI, for example. They are executing a complete pivot.
Yeah, they really are.
They are building this desktop super app that unifies ChatGPT, Codex, and browsing all into one single workspace. And to pull this off, they're actually cutting their side projects.
Which is a huge deal for a company that size.
Right. They're putting all their resources into agentic capabilities that work autonomously right there on your local computer.
And the reason this is happening now, well, it really comes down to the underlying models. The engines powering these agents are becoming incredibly fast and just shockingly cheap. We are talking about models like OpenAI GPT 5.4 Mini and Nano.
Oh, those smaller models are wild.
They are. Or look at Cursor Composer 2, which offers these really fast variants of frontier-level coding models. When the intelligence becomes this cheap and this fast, your entire relationship with the tool changes. You stop treating it as an expensive reference encyclopedia, and you start treating it as disposable, high-speed labor.
It is exactly like moving from having a really smart encyclopedia sitting on your desk that you have to manually search through to hiring a hyperactive intern who just takes your mouse and starts clicking around your screen. And companies are already deploying these systems at scale.
Oh, absolutely.
Stripe, for example, has these internal bots they literally call minions, which is a great name. And these minions are shipping over 1,300 pull requests a week.
Wait, 1,300?
Yeah, a week. They are operating entirely in isolated cloud sandboxes, which means they can break things, they can test things, and iterate without taking down the main production servers.
That volume is just staggering. 1,300 pull requests is an output that would normally require a massive team of human engineers working around the clock. And Anthropic is doing something very similar. They are using hundreds of internal skills for Claude Code to accelerate their own development.
So they're building the tools that build the tools.
Exactly. It is turtles all the way down. And this leads us directly to a properly fascinating new way of working that developers are calling the night shift workflow.
Oh, I love this concept. Let us get into how this actually works. So the human developer spends their day shift doing the high-level architectural thinking, right? They write the specifications, they set up the context, and they define the exact boundaries of the problem, basically prepping the workspace.
Right, they set the stage.
Yeah. Then when they clock off for the night, the agents take over and code autonomously overnight. The human wakes up, grabs their morning coffee, and just looks at the finished work. But hold on, let me play devil's advocate here for a second.
Go for it.
If we have these hybrid orchestration setups and night shift workflows just churning out code while we sleep, who actually understands what is being built?
Well, that is the multi-billion-dollar question right there. And it leads directly into a severe human problem. Because this explosion of autonomous coding creates a rapidly widening gap between what the machines build and what humans can actually understand.
Right.
In software engineering, this phenomenon is known as comprehension debt.
Comprehension debt.
Oh, okay.
Okay, let's explore this, because if you manage a dev team, I reckon you have probably already felt this friction.
Oh, you definitely have. It is essentially the hidden cost of AI-generated code.
Yeah.
Because you have to remember, code is not just a set of mechanical instructions for a computer. It is a historical record of human decisions.
Oh, that is a good way to put
Yeah,
it.
like, why was this function written this way? Why did we choose this specific architecture over another one? When an autonomous agent generates thousands of lines of code overnight, teams quickly reach a point where they can no longer explain why certain design decisions were made. They completely lose track of how different parts of a complex system actually interact with each other.
So it is like taking out a mortgage on your code base. You get the big, beautiful house immediately without having to build it brick by brick, but you owe a massive debt of understanding.
Spot on. And the interest on that debt accrues incredibly rapidly. That debt comes due the exact second a complex system breaks in production, and no human on your team actually knows how to fix it because none of them built it.
But wait, let me push back on this a bit. Is this not just the exact same panic we had when calculators were invented?
How do you mean?
Well, people thought we would forget how to do basic math. Is writing all that boilerplate code not just the modern equivalent of doing long division by hand? Like, if the autonomous agent is fundamentally better at the syntax and never forgets a semicolon, why do we need to memorize the underlying mechanics?
I hear that argument a lot.
Right, because aren't we just evolving into directors instead of actors? We just tell the machine what we want and it handles all the tedious typing.
It is a very tempting way to look at it, mate, but managing an autonomous agent is fundamentally different from using a calculator.
Okay, why?
A calculator does exactly what you tell it to do, strictly step by step. An autonomous agent makes thousands of independent micro-decisions on its own just to achieve a broad goal. A software architecture is not just a collection of correct syntax. It is a really delicate ecosystem.
Yeah, fair enough.
When you outsource the fundamental building blocks of that system, you lose the intuitive understanding of how that system functions under extreme stress. You simply cannot effectively manage or debug a system if you do not understand its foundational logic.
I see what you mean. So relying entirely on a really fast typist carrying out your broad instructions works absolutely perfectly, right up until the typist hallucinates a critical bug that crashes your entire platform at 3 in the morning.
Exactly.
And then you are a senior engineer staring at millions of lines of code you did not write, trying to find a microscopic ghost in the machine.
And we are already seeing the very real human impact of this shift, especially at the entry level. Computer science students are reporting feeling incredibly apathetic about their careers.
Oh, well, really?
Yeah, they are looking at the market and realizing that AI can easily perform those standard entry-level junior developable tasks.
Which completely breaks the human training pipeline. I mean, how do you get senior engineers in 10 years if there are no junior engineers right now?
Precisely. University teachers and industry mentors are actively struggling to figure out how to teach senior engineering fundamentals without the hands-on experience that junior roles usually provide.
Because you do not just wake up one day as a senior engineer with brilliant judgment.
No, you build that judgment over years by making mistakes on the small stuff, by fixing minor bugs, by reading terrible code written by other humans. If the AI does all the small stuff flawlessly, humans never build the muscle memory required to tackle the big, complex architectural failures. We are basically treating human comprehension like a legacy system we are trying to phase out.
Which is a wild concept. And the corporate reaction to this efficiency is completely ruthless. Look at Meta. They are reportedly planning sweeping layoffs that could affect 20% or more of their workforce.
That is a massive chunk of their staff.
It is huge, and they are doing this specifically to offset massive infrastructure costs and lean entirely into this idea of AI-assisted worker efficiency. They are literally replacing human comprehension with machine output just to save on the bottom line.
But there is a brutal physical limit to this endless software automation.
Right, the hardware.
Exactly. To run an army of digital interns and facilitate these massive autonomous night shift workflows, you need an incomprehensible amount of physical compute power.
Yeah.
This software evolution is forcing the entire hardware industry to execute a really violent pivot.
Let us get into that hardware bottleneck, because this is where the physics actually meet the code. NVIDIA CEO Jensen Huang is projecting $1 trillion in AI chip sales as the computing era shifts heavily toward inference.
$1 trillion. Just let that sink in.
It is an absurd number.
Oh.
And what is brilliant here is that the standard graphics processing units, the GPUs we have been relying on for years, they are not actually ideal for this inference phase.
No, they are not. They have massive energy consumption issues, and severe memory limits when it comes to inference.
Right, so we are seeing entirely new hardware architectures emerge, like the Blackwell and Rubin chips.
But the real surprise here is where the bottleneck has actually moved. NVIDIA is making a massive push into central processing units, CPUs. Specifically, they are pushing these agentic, optimized Vera CPUs that feature 88 distinct cores.
Okay, so the big reveal is that after years of relentless GPU hype, we are suddenly scrambling for CPUs again.
We absolutely are.
Because apparently that is where we are now. It feels like we are going backward a bit.
It does feel retro, but the reason why requires a bit of mechanical context. We spent years obsessing over GPUs because they are incredible at parallel processing.
Right, doing heaps of things at once.
Exactly. That is exactly what you need to train a massive AI model. You're doing millions of tiny math problems all at exactly the same time. But inference, especially when you are dealing with autonomous agents, is a completely different beast.
How so?
Agents are constantly retrieving context, searching local file systems, running scripts sequentially, and moving massive blocks of data around. That requires sequential processing and managing heavy data traffic. So the CPU has suddenly become the new traffic jam.
I get it. It's like building a massive V8 engine for a race car, but completely forgetting you need fuel lines wide enough to actually feed the engine. You have all this processing horsepower sitting there, but absolutely no way to get the data where it needs to go fast enough.
That is exactly what is happening, and the financial scale required to build those wider fuel lines is just staggering. We are seeing capital consolidation on a level that is genuinely hard to wrap your head around. Jeff Bezos, for example, is reportedly in talks to raise a $100 billion fund.
Wait, 100 billion with a B.
With a B.
That is the gross domestic product of a small nation state, just sitting in a venture fund.
Yes, and the explicit goal of that fund is to buy up physical manufacturing firms across chip making, aerospace, and defense, specifically to automate them top to bottom with AI.
Oh, wow.
He is looking to build a fully automated industrial base that operates entirely on agentic workflows.
That is wild.
Yeah.
Meanwhile, if you look at China, they're taking a completely different approach to mobilize this exact same technology.
Yeah.
They're heavily incentivizing one-person AI startups.
Yeah, the state support there is fascinating.
It is. The government is literally offering solo founders free apartments and converting idle data centers into massive technology incubators. They are relying heavily on national policy and state infrastructure rather than just Silicon Valley venture capital.
It is a massive state-backed push to ensure they have both the compute and the human talent to dominate this next phase of autonomous systems. They clearly understand that compute is the baseline utility required to build absolutely anything else in the modern economy.
Like electricity.
Much like the electrical grid in the 1920s. If you do not have the grid, you simply cannot build the factories.
Okay, so let us pull all these threads together. We have limitless compute being built. We have unlimited funding pouring in from tech billionaires and sovereign nation states. And because of all this cheap infrastructure, the intelligence is finally spilling out of our desktop screens and into the physical world in some truly bizarre ways.
This is where the lines between software and physical reality completely dissolve.
Yeah.
Once intelligence becomes a cheap, abundant resource, you do not just leave it in a web browser. You start putting it into absolutely everything that moves.
Which brings us to Travis Kalanick, the co-founder of Uber. He has this stealth company called Atoms, and they are creating what they literally call gainfully employed robots.
Which is such a weird phrase.
It really is. But they are building a physical workforce for the food, mining, and transport industries.
So it is taking that invisible digital intern we talked about earlier and giving it a highly capable physical body to do manual labor. But the biological applications are where the mechanics get truly strange.
Oh yes, I wanted to get into this.
Researchers have successfully mapped a literal fruit fly brain and then uploaded it into a digital environment.
I read about this, and it is properly wild. But explain how that actually works for us. We map genomes all the time. What makes uploading a fly brain different?
Well, they did not just map it as a static image or write an algorithm that mimics how a fly acts. They mapped the entire connectome.
The connectome, meaning the wiring.
Exactly. Every single biological neuron and every microscopic synapse connecting them. Then they recreated that exact biological wiring diagram in a software simulation. They did not write any traditional code telling the system how a fly behaves. They simply attached digital sensors to this virtual brain and provided digital stimulus.
And the virtual brain just instinctively knew how to be a fly.
Yes. The virtual neurons actually respond to the digital sensors in completely authentic, fly-like ways.
That is incredible.
The biology literally became the software. It processed the digital stimulus through its biological architecture and produced genuine behavior. Grooming, walking, reacting to light. It is a perfect digital twin of a biological system.
And the implications for human biology are tracking right alongside those digital flies. China has just approved its first ever commercial brain-computer interface for paralyzed patients.
A massive milestone.
It is. They are treating this human-to-machine connection as a core strategic industry. Which, yeah, is exactly as terrifying as it sounds. We are uploading digital fruit flies and plugging human brains directly into machines that can control software with their physical thoughts.
It sounds like a movie plot.
It really does. And if that is not enough science fiction for you, we are taking this exact same compute architecture to space.
Space is the absolute ultimate hostile environment for physical compute, which makes it the ultimate proving ground for these new hardware systems.
Right. There is a company called True Anomaly building the Jackal spacecraft. It is essentially a fridge-sized flying fuel tank designed for orbital dogfighting.
Orbital dogfighting.
This casual space battle.
Just casual space battles, it can rapidly turn, approach, and surveil other objects in low Earth orbit. And to power this kind of off-world intelligence, NVIDIA is building these Vera Rubin Space One chips specifically for orbital data centers.
Right.
And here's the kicker. They are having to figure out how to cool the systems using just radiation. Explain that, because normally to cool a server rack, you just blast it with air conditioning, right?
Exactly. On Earth, we rely entirely on convection. You blow cold air across a hot surface, the air absorbs the heat, and then fans push that hot air away.
Simple enough.
But space is a vacuum. There is no air to carry the heat away. If you put a standard server rack in orbit and ran an agentic workflow on it, it would literally melt itself into slag in a matter of minutes.
So how do you actually cool a supercomputer when there is literally no air? You have to convert the thermal energy generated by the processors into infrared light and literally radiate it out into the absolute void of space.
Oh, wow.
Yeah, it requires completely rethinking the thermal architecture of the chip itself, designing materials that can emit heat as electromagnetic radiation efficiently enough to keep 88 processing cores from catching fire in a vacuum.
It is absolutely incredible engineering. If we connect all these disparate facts together, what we are seeing is that intelligence and compute are now physical commodities.
Absolutely.
They're being bolted onto everything from deep space asteroids and orbital dogfighters to autonomous mining robots and human nervous systems. We are beginning to treat artificial intelligence like electricity, just this invisible, ubiquitous utility that powers the physical world seamlessly in the background.
It brings us right back to our original thought experiment. If you can just hand your laptop to an invisible intern, or bolt a radiation-cooled supercomputer onto a satellite to do your orbital math, raw intelligence itself just becomes a cheap, unlimited utility.
So here's a thought for you to mull over as you go about your work. If raw intelligence, coding, and basic problem solving are just cheap utilities we pipe into everything from desktop software to space satellites, what actually becomes the true premium skill for human beings?
It is the defining question of our era. When the machine can code, reason, and operate physical robots infinitely better and faster than we can, our fundamental value stops being about producing the right answers.
Right.
Our value has to shift entirely toward asking the right questions. We have to become the architects of the intent rather than the laborers executing the details.
Something to keep you up at night next time you're staring at a blinking cursor.
Ah!
Thanks for exploring this with us on Vocal Technologists. What is left for us when the intern finally does everything? We will leave you to figure that one out.
Spoken Tech, for your ears.